density altitude. Density altitude is that altitude at which existing density would occur in the ISA, density at which temperature will occur in ISA, the elevation at which existing density would occur in ISA. So before you do this question or do this video, I would also strongly suggest every one of you to watch the density altitude part 1, density altitude part 2 videos that I have done. I have uploaded them in the playlist of knowledge series. I will also put the links of them in this description box. So watch those videos and then you can come to this lecture. Apart from that, the definition is option number A. Your density altitude is that altitude at which the current density or the ambient density around you will find in ISA, right? You may be at mean sea level. At mean sea level, your density should be 1013 according to ISA. But if current density is, let's say, 50% of that, 50% or half of 1013, that means you will have density which is supposed to be found at 20,000 feet in ISA. So pressure altitude may be 0 feet, but density altitude will be that altitude at which you are going to find the ambient density around you, 20,000 feet. So by definition, the altitude at which the density would occur in ISA. Elevation. Elevation is also a right word, but pressure altitude can only be substituted with elevation when airport is at mean sea level. But otherwise stated in the question, don't select option Charlie, select option A. Question 31. Pressure altitude of the field, that is your airport, can be found by what procedure? Now you know pressure altitude is that altitude which is indicated by the altimeter when 1013 pressure setting is put in the subscale. One more important thing is that pressure altitude, true altitude, indicated altitude, flight level, height, all these things, radio altitude by radio altimeter. These types of altitude are shown by the altimeter based on the pressure setting that you put in it. Radio altimeter is one exception in which the principle is based on radio waves. Okay, and then the third unique exception is density altitude. Density altitude is not obtained from any pressure setting from the altimeter. You calculate that manually before your every flight for your departure aerodrome conditions and landing airport atmospheric conditions. Coming back to this question, so the pressure altitude is obtained by putting 1013 in the altimeter pressure setting window. Question 32. If pressure altitude is 5000, outside temperature is 25, what is the density altitude? So density altitude is pressure altitude plus 118 into ISA deviation. Ignore this minus sign, okay? So now we have to put the given values in the question in this formula. So pressure altitude is 5000, so 5000, 5000, 5000 plus minus plus. So option B can be eliminated. Now we are remaining with option A. We are left with option A and C. 118 everywhere, okay, A and C, into ISA deviation. Now ISA deviation can be rewritten as 15 minus 1.98 into 5000. So 15 minus 1.98 into 5, 15 minus 1.98 into 5 is here, 15 minus 1.98 into 5 is also here. Okay. After that, we have outside temperature 25, right? To find ISA deviation, this is the formula for ISA temperature. ISA deviation is what? ISA deviation is outside air temperature minus ISA. Outside air temperature is how much? It is 25. So 25 minus big bracket this ISA temperature value 15 minus 5 into 1.98. This you will find 25 minus 15 minus 5 into 1.98 here, 25 plus. Actually, formula says minus. So option C is also wrong at this point, 25 plus point. Okay, but this is correct sequence. So option A will be the correct option. If you solve the whole equation, you will get this answer. So let's go to question number 33. So this is a potential question for DGCA. All that they have done is substitute the values. This ISA deviation is enlarged into this 25 minus outside air temperature minus ISA temperature as a whole. So ISA temperature can be further obtained like this. So they have put it there. Question 33. QFE is 1022. What is the pressure altitude of the field? Now QFE is the aerodrome level pressure. So let's say this is your airport, right? This is your airport. So QFE equals to 1022. Do you agree? So this is what they have given in the question. Airport QFE aerodrome level pressure. What is the pressure altitude of the field? Now pressure altitude is obtained from a pressure setting of 1013. 1013. Now 1013 is less in value than 1022. So this pressure line or this pressure datum will be drawn on top of QFE. So 1013 will be above the 1022 pressure datum, right? So as you go higher up in the atmosphere, atmospheric pressure decreases. That's why 1013 will lie above 1022. So the final diagram will be this. Airport is here. QFE is 1022 and standard pressure setting is 1013. So now what is the pressure altitude of the airport? So pressure altitude will be measured from 1013. So like this. But from this diagram you can clearly see that airport is below the standard pressure setting datum. So pressure altitude will be negative in value, indicating that our airport is below the datum. So negative what value? So let's find that out. So what is the pressure difference? Pressure difference is 1022 minus 1013, 9 millibars. That will give you a height difference of 9 into 30, 270 feet. So pressure altitude will be minus 270. Why? 1 millibar is equal to 30 feet. Therefore, 9 millibar will be equal to 270 feet. So this is 270. Pressure altitude is 270. But minus. So minus 270 feet is your pressure altitude. Next. Which of the following will cause air density to decrease? Air density to decrease. After having watched density altitude videos, you will have known that density altitude is controlled by three factors: pressure, temperature, and humidity. Pressure, temperature, and humidity. Pressure, temperature, and humidity. Density decreases when density decreases when first pressure decreases, temperature increases, and when there is humidity in the air. Humidity in air. That will cause your density to decrease. So when density decreases, In other words, you can also say density altitude increases. So which of the following will cause air density to decrease is increasing humidity, yes. Increasing altitude. With increase in altitude, pressure decreases. So pressure decrease, so density decrease. So that is right. Increasing temperature, that is also right. Increasing temperature means more kinetic energy, more space the molecules will get to move. So this is correct. Option A is the correct option. Increasing humidity, option B, right. Decreasing altitude. Decreasing altitude means more and more static pressure, more and more density. So this is wrong. Decreasing humidity. Decreasing humidity means air gets drier and drier by that much. So that will increase your density, not decrease it. So option C is wrong. Let's go to question 35. Before that, very important fact. Relationship between QNH and QFE. Relationship between QNH and QFE. So QNH is the ambient air pressure at mean sea level. QNH and QFE. So before we do the next question, this important fact you have to remember. Now QNH and QFE. To understand that, listen to this. This is your airport and this is your mean sea level. The pressure existing at airport is QFE. Pressure existing at mean sea level is QNH. Right? Now the relation between QNH and QFE is that they are both joined by elevation. Elevation. So elevation is what separates them, right? Is what unites them. Depends on your perspective. So that is the relationship between both of them. And another important thing is that when QFE air pressure increases, simultaneously QNH pressure will also increase. When QFE pressure decreases, QNH pressure also decreases, vice versa. Remember that. When QFE increases, QNH will also increase. QFE decreases, QNH will also decrease. Okay? Because they both are joined by elevation. Unless there is an earthquake and there is a land tectonic movement, the elevation of any airport, of any mountain, or any other place you take on the earth will not change automatically along with changes of atmospheric pressure. And therefore, change in QFE pressure will automatically cause a equal change in QNH pressure. Okay, so QFE is what? QFE is aerodrome level pressure. QNH is what? Aerodrome level pressure reduced to mean sea level. Aerodrome level pressure reduced to mean sea level. Reduced to here means converted to. Converted to. Remember that. So, QNH is ambient air pressure at mean sea level. QFE is ambient pressure at airfield elevation. The two are related in that any increase in one results in an equal increase in another. Elevation of an airfield is its vertical distance from mean sea level. Elevation does not change with varying atmospheric conditions. Elevation doesn't change with varying atmospheric conditions. Question 35. If QNH changes from 1013 towards 1022, okay, what will happen? Now QNH has changed from 1013 and become 1022. That means what has happened? There is an increment. There is an increment correct? So if QNH has increased, as a consequence of that, QFE will also increase, and as a result, the elevation of the field will remain the same. Elevation won't change. Today airport is 10 feet above mean sea level, tomorrow 20 feet, no. Unless anything happens in the earth, nothing like that will happen automatically with atmospheric pressure conditions. So QRH increase, QFE should also increase, but QFE option is not here. The option is about field elevation. Will field elevation keep on changing day to day, time to time with atmospheric conditions? No. So it will not affect field elevation because QNH increase is also QFE increase. So the constant. So elevation will remain constant. No change in that. 36. QFE increases from 1013 to 1022. QFE increases from 1013 to 1022. So what is the consequence of that? So when QFE increases, QNH also increases, right? Elevation remains same. Elevation remains the same. So correct option is increase elevation, no. Not affect QNH, no. Wrong. QFE increase, QNH also increase. So option C is the correct answer. 37. Elevation 4000 feet above mean sea level, QNH 1025. What is pressure altitude? So we have done this before. So this is your airport. This is your QNH. Elevation is 4000. Pressure altitude is how much? Pressure altitude is measured from 1013. Standard pressure setting 1013. So pressure altitude will be measured between airport level and 1013 level. That will be your pressure altitude. So now this entire thing is 4000, right? Let's find out this difference. Let's find out the difference between these two. When you know that difference, you will subtract that from the entire 4000 feet and you will get this part. From this big part, when you subtract this small part, you will be left with this much part, which is your pressure altitude. So let's do that. Pressure difference equals to 12 millibars, and therefore the height difference will be 12 into 30 is 360 feet. So this is 360, and therefore pressure altitude is 4000 minus 360. So 4000 minus 360 is how much? 3640. So this is 3640. So the correct option is option brown. Okay. So simple subtraction. So draw the diagram, label it. When you label it, you will get the overall picture. And then just stick to the basics. Pressure difference is height difference and pressure altitude is that much, 3640. Question 38. As altitude increases in the ISA, altitude is increasing. The effects of decreasing pressure outweighs those of decreasing temperature, meaning the decreasing pressure outweighs, that means dominant. Outweighing something means being more dominant than something, or being more powerful than something, or having more effect or consequence than some other thing. So the effect of decreasing pressure outweighs those of decreasing temperature. That means pressure is dominant factor compared to temperature. So aircraft performance decreases because when pressure decreases, density decreases, performance decreases. So option A is correct. The effects of decreasing density outweigh those of decreasing pressure and temperature, so performance decreases. So this is wrong. This order is wrong. And C is also irrelevant. The effect of increasing true airspeed to CAS not relevant. So question 38, option A is the correct option. I have covered this very specifically in the density altitude part 2 video. You have to watch that. Next. Before that, a quick recap. When pressure decreases, your density should decrease. When temperature decreases, density should increase. So the ISC states that in one condition density is decreasing, in another it's increasing. So what will be the final output? The final output will be density decrease, and that will only be possible when pressure is more powerful than temperature. Otherwise density would have increased, right? But that is not the case because pressure is overpowering temperature, and therefore option A is the correct option. With this, we come to the end of this productive lecture. I hope you have understood all these objective questions, scoring questions. So it's a humble request that you do these questions again and again and solve them, so that whenever you get these questions asked, any exam you take, CPL, ATPL, airline, don't miss out on these questions. Don't lose these easy marks. Okay. So practice them again and again. Read the chapter, watch the videos I put in the description box. Okay, don't overlook that. With this, I hope you have understood everything. You have liked the lecture, hit the like button, subscribe to this channel, keep getting timely updates, and share this video with all your friends. It would be a huge favor. Thank you. All the best.